Hello and welcome to another lecture. In this lecture, we are going to discuss about Lambda expressions in Java. So Lambda expressions are a great feature which was introduced in Java 8. It was a big breakthrough release in which many new features was introduced in Java 8. Along with that, the functional programming constructs was introduced into Java after Java 8. So one of the key functional programming construct is Lambda expression. So in this lecture, we will start discussing about Lambda expressions. So let's start. So Lambda expressions are certain syntax for a code which allows concise representation of implementation of functional interfaces, and it allows us to have reduce the code and represent our functional interfaces implementation in a much more simpler manner. Before Lambda expression, we have to use anonymous inner classes and other concepts to implement the functional interfaces. And but Lambda expressions provides a very simple syntax in which we will be able to easily declare implement the methods which are present in the functional interface. So what is a functional interface? So functional interface is an interface which consists of a single abstract method. So if an interface has a single abstract method, then that is a functional interface. So you can use the at the rate functional interface annotation to mark the particular interface as functional, and this is how this functional interface will work. And it has a single abstract method, so whenever we want to use that interface, we have to implement that interface is single abstract method. So to do that, we have the syntax of Lambda expression. So Lambda expressions, let us see the syntax for Lambda expressions. So here you can see the left hand side of the lambda expression will be containing the parameters for the lambda, which will be the parameters for our method in the passing in the functional interface. Whatever method is there, that single method's parameter, whatever list is there, we have to supply it to as the lambda's parameter. And the right hand side of the as in after arrow notation, you have to provide after the arrow notation, we have to write the body of the particular functional interface. So like that method we will be able to implement without having much worry. So before that, we have to declare anonymous inner class and we have to implement the particular method. Like that you have to create the particular implementation of the functional interface. So now it is reduced. In some cases we can reduce the length of the parameter. This syntax also we will discuss when we go through the practical of this lecture. And now let us discuss about some of the advantages of lambda expressions. So lambda expressions, when you create lambda expressions, there will be no class files generated, extra class files are not generated. And so lambda expressions reduces that part of the code, and in the no extra classes are required. And lambda expressions allows reduces the amount of code which we need to write. So it will be we need to just write few lines of code in case of lambda expression. If you use an anonymous inner class or other classes, we have to write more code. So here we can reduce the code amount of code. And the next thing to understand about lambda expressions is it will implement automatically, it will implement the functional interface for us. So that is a great feature to have. So that is about lambda expressions theoretical aspects. Now let us see some practical programs based on lambda expressions. Thank you. Now in this program we will go through the syntax for lambda expression, how we can declare lambda expressions. In this program we will see. So before that we will have some functional interfaces to write our code to implement our lambda expressions. So let us see the functional interfaces. So here you can see addable is a functional interface which has a single method add, which take two parameters. So that is it about functional interface addable. It is marked with the iterate functional interface annotation. And next interface is incrementer. So incrementer interface has one single method which is increment, which is having a single parameter, and that is it about incremental interface. Now let us see the next interface. So the next interface is printable. So printable interface has a single method print which is not having any parameters. So that is also a functional interface. Now let us see the main method to see the lambda expressions. So here we are in the main method of our program. So first I'm using the creating the lambda expression for the printable functional interface. Here you can see the syntax. In the left hand side of the arrow notation you can see the parenthesis, and in the right hand side of the arrow notation I have provided the implementation of the uh, particular functional interface which I want to implement. Method body of the particular function print. So like that we can provide. So here you can see I don't need any braces to cover it if it is in the same line. And next is I am using the method print to call the particular print after getting the object. So next interface is incrementer. The incrementer interface, similarly I am using the another lambda expression to implement the incrementer interface. So here you can see this is a syntax. So here I am using having a single parameter, so at the time you can avoid the parenthesis and directly provide the variable here and then use the particular notation. So this will create the implementation of the increment method. Whatever the body of the increment method is there, that part will write. And that's it about the incrementer interface in implementation. And I'm calling the particular increment method. And after that I am using the addable implementing the addable interface which has two parameters in the particular abstract method, which is add method. So here we can see I am having supplying the parameters for the lambda and followed by the arrow notation of the arrow. After the arrow notation I am writing the body of the particular function interface method, and like that I am adding the particular method, and after that I am calling the sum method. So that's it about this program. Let us see the output. So here we can see all the values are getting printed. The add, the incrementer, and printable. All the method, all the interfaces are working correctly. So this is how we will use lambda expressions in a program. Now let us see another program based on lambda expressions. Now let us see a program based on useful feature about lambda expressions. We will use lambda expression to use a functionality in the comparator interface called as comparing functionality. So we will use the particular method in the comparator interface to see how it is working. So we explained about comparator interface in the arrays and collections lesson. So it is about sorting the data, user defined data, and we will use the comparing method in the comparator interface in this program. So let's start. So here is the object class which I will have the user defined class for this particular implementation. So here is the class employee. It has ID, name, and salary, and constructor is declared, and the toString method is there. So now let us go to the main method. So here you can see the main method of this program. Initial part of the main method, I am adding the employee objects, creating the employee objects, and adding it into an array list one by one. And after that I am using the comparator object. I'm creating a comparator object, and you can see comparator dot comparing of lambda expression I am passing. In this lambda expression I will pass in the particular name. Here you can see I'm not placing any return statement. It will automatically find out the name is a return value, and it automatically returns that value for us. And this is how a syntax for lambda expressions you can use. And here you can see based on name it will sort. So this is the first feature of the comparing method in the comparator interface. Now, after that I am using the sort method and I am passing the comparator object. So that will sort the particular data. Let us see the output of this program. Here you can see the output as came. The values are sorted. The data is sorted with the ascending order of the names. So here you can see it is sorted based on names. So that's it out out of this program. In this lecture, we are covered about lambda expressions in Java, which is a key concept in which was introduced in Java 8, which allows us to implement the functional interfaces with very simple syntax. So here you can understand the syntax. And the important thing to know is that some of the syntax we can reduce it. We cannot we can avoid some parentheses and all. We can reduce the complexity of the lambda expression and make it more easier to understand. So lambda expressions is a key concept we have learned in this lesson. Thank you for watching this lecture. I will be back with the next lecture. Thank you. Hello and welcome back to another lecture. In this lecture, we will discuss about more functional programming. So in this lecture, we will discuss about a method reference, which is a compact form of lambda expression, which will reduce the code even further. So let us see this lecture. So in this method reference is a compact form of lambda expressions, which can be used to refer to a particular method of a functional interface. And it is a compact form of lambda expression, as we discussed. And the another thing about it is it can be used whenever we are using the lambda expressions for referring to a particular method of the functional interface. So we can replace it with the uh, lambda expression can be replaced it with the method references. So with the syntax of method references is it is a colon operator is there and followed by the particular method you want to refer. There are three different types of method references in Java. The first one is the instance method reference. So instance methods can be referred using the method reference. And second is the static method reference. So you can refer the static methods in the particular class using the static reference. And you can also have constructor reference using the new keyword. You can refer to the particular constructors. So that is about method reference. Now let us see some practical programs based on method reference. Now let us discuss about some programs based on method reference in Java. So method references are you seen it is to symbol notation for lambda expressions. It is to simplify the lambda expression and make it more concise. So let us see. So in this program, we are going to have a method reference for a particular interface called as function interface printable. So here printable interface is there and it has a method is print. It is a function interface. Now let us see the method references of this particular interface. So here you can see this is the main class in which I will write the particular method reference functions. So methods you can see all that there are different static and non-static methods are available are created and the constructor is also provided. So let us see the main method of this program to understand about method reference. So here first you can see the I am creating a method reference of the particular static method reference. So here you can use the class name followed by the particular method in the particular class. So like that we can use as a use to call refer using the static method reference. So that is how, and I'm calling the print method after creating the object. Now let us go for the second one. So second one is the non-static method reference. In that case I'll create an object first, then use the object call double colon operator and followed by the particular method which I want to invoke in the particular interface. So after that I will print the particular message, call the print method, and after that I am using the third syntax which is the constructor method reference. Here you can see followed by the class name. I have provided the new operator, so it will be used for constructor method reference. So it will refer to the constructor reference. Now let us see the output of this program. So here you can see all the method references are coming correctly and the values are printing correctly accordingly. So that's it about method reference, some of the examples. Now let us see another program based on method reference. Now let us discuss about method reference another program. So in this program we will go through a bifunction interface. Bifunction interface has a single abstract method called as apply, and this is a function interface and we will see the program how we will have the bifunctional interface to work. So here we are in the main method. In this program, we are going to add two numbers using the bifunction interface. So let us see the program. So here you can see the add method, which will take two parameters and return the sum of the two values. So that's it about that method. And then go to the main method. I am declaring the bifunction interface and using the method reference of the particular class addable, and using the add method as the method reference for that particular interface. And after that I'm calling the apply method with two supplied values. So let us see the output. So here we can see the output as generated. So this is working fine. The values are getting calculated. The sum is getting calculated. And in this lecture, we are seeing about method references in Java, which is a compact form of Lambda expressions in Java. So it is more further simplified than Lambda expressions. So we can use method reference when we want to substitute our method with a particular method, and we can implement all the functional interfaces like this also. And thank you for watching this lecture. I will be back with the next lecture. Thank you. Hello and welcome back to another lecture. In this lecture, we will discuss about predicate in Java. So we are seeing about functional programming. So this is a key feature in functional programming to have a predicate function. So let us see the predicate function, how predicate interface is designed and how it can solve our problems. So let us see. So predicate is an interface which consists of a single functional interface which consists of a single abstract method called as Boolean test. So it will return you a boolean while other value the condition failed or success, that will return the predicate will return you the value. And the predicate interface is found in the java.util.function package. So in that package there are more functional interfaces. Please take time to explore all the functional interfaces which are present in that package. So now let us discuss some of the methods which are present in the predicate. So there is an add method, test method which we already know, which will be used for our the we implementing the lambda expressions everything based on the particular test method. And after that there is an or and negate method is there. Is equals method is there. Is equal method is there. So there are different methods which are present in the predicate, and the only abstract method which is present is the test method, which is our key method. So let us go to the programming part. Now let us see some programs based on predicates. Now let us see a program based on predicates. So in this program we will explore about the predicate in Java. So let us start. So here you can see double predicate. This is a particular interface belonging to the predicate type interface. So here you can see a boolean test method, and it will return take the parameter of double value and return you a boolean statement whether it is true or false. So let us see the main method of this program. So we are in the main method. So I am implementing the double predicate and by using the lambda expression. So here I am checking for a particular condition, the value is greater than 10, then it will return true, else it will return false. So that is the state body of the particular test method it will be implementing. And after that I am calling the test method with the two different set of parameters. So that's it about this program. Let us see the output. So here you can see the double predicate is printing the particular results. So if value was that the condition was whether greater than 10, so the time it is the condition is successful, so it will test method return true. And if the condition is failing, that time less than 10, that time the value is returning as false. So this is how a double predicate is working in Java. So let us see another program based on predicates. Now let us discuss about another program on predicate. In this program, we will use predicate to filter out a particular data collection. So there will be a list of students, and I will sort them on the students based on their age. So let us see this program. So before that, first we will have a student class. Here you can see the fields ID, name, and age. So there is a constructor and a toString method. Now let us see the main method. So you are in the main class. So in this main class, I have the main method. In the main method, if initial part I am just creating the particular student object and inserting into the list. So I'm creating the list and adding it all the values into the particular list. And now I'm using the predicate, creating the predicate object. Here you can see the predicate object I'm creating. So it's a generic type of predicate. You can see here in the angle brackets I will pass the particular student, and I will create the particular predicate using the lambda expression syntax. So here the condition is id age greater than 25. So that is a condition which I provided, and that will be our predicate. And now after that I am using the Streams API to filter the particular collections. We learn about Streams API in the next lecture. So now let us. It is an API to aggregate and aggregate and process the collections. So let us see this. So I am using the stream method, which will return me a stream object, and on that object I will use the filter method. So the filter method will take a parameter of a predicate interface. So I will pass a particular predicate object, and after that I am using the for each method in the particular streams API. So we can use the for each method to iterate through all the particular elements in the particular collection. And after that, I am using the method reference of the system.out println to print the particular values. So we can see that I am using the method reference, predicate, and lambda expression, all the three concepts of the functional programming in this program. So let us see the output of this program. So here you can see only the values which are filtered are coming. So that is it, our output of this program. You can see the values which are filtered according to the predicate condition is only coming. So that's it for output of this program. Now let us see another program based on predicates. Now let us see another use case of predicates in Java. So in this program I am going to create a collection, a set, and from that set I will remove the particular elements satisfying the predicate condition. So let us see this program. So in this program I am using a hash set. In the hash set I am putting the particular values. So the values inserted numeric values, number values, integer values. And then let us see, and after that I am using the predicate condition. So the predicate condition, before predicate condition I will use the remove if method. So remove method is present in the set in the interface, so we can use that particular method, and it will call the it will remove the based on the predicate what we are supplied. So here we are supplying a lambda parameter as a mm, predicate, and condition is greater than 25. So that condition will be satisfied, then all the values will be removed. Let us see the output of this program. So here you can see the output. So the all the values which are greater than 25 is removed from the particular set. So that's how this will work. Predicate will work in case of remove if. So we can use predicates are everywhere in this program. There are many places, other places where we can pass predicates and remove. We can filter the collections. All the things can be processed using predicates. So thank you for watching this lecture. I'll be back in the next lecture. Thank you. Hello and welcome back to this lecture. In this lecture, we will discuss about Streams API. So this is a very core concept in functional programming to know about Streams API. So it is introduced in Java 8. It consists of many classes which will implement the Streams API. So it is part of the Java.util.streams package. And what first thing to understand about streams is it is used to aggregate and process collections. So collections or arrays or any data structure, we can use the streams, and we can you can process the particular collection and aggregate its values such as count, average, everything can be used get using the stream API, and it is used to process the collections also. So if you want to filter a particular value from the particular collection, and there are two different types of streams. This is sequential stream and parallel stream. So sequential stream will execute the program sequentially one after the another. So the each item in the particular stream will be executed one after the another. But in parallel stream, they will be executed parallelly using the feature of multi-core processors which are available in the market. So parallel streams will process them parallelly, which means we are not sure that which one will execute the first, like that it will be. And now let us discuss more about streams. So next thing which we'll discuss is streams methods. So streams has a lot of methods. So these methods will be used for aggregating as well as aggregating the collections, as well as for processing the collection elements, mapping them, flat mapping them, and checking for other predicate conditions, filtering them, and uh, finally there are some aggregate methods also. So there are two different types of operations in streams: terminal operation and intermediate operation. So in terminal operations will enter the stream and will return you a particular value, whereas intermediate operation will return you a particular stream, and you can continue using the other intermediate operations, so that you can use multiple intermediate operations and one terminal operation in a particular stream. So like that, and stream can be closed using the close function. So let us see the other functions which are present. Let us see more functions. So here there is another functions and little more functions. So this is more functions on streams. So these all functions are related to functional programming. Most of them are related to functional programming. The aggregate count, these methods are for aggregating the collection and printing the values. And let us see some of the programs based on the streams API to understand more about these methods. Now let us discuss about a simple program based on streams API. So in this program we will have different types of streams, and we will try to add some values into the stream and use some of the methods to filter the particular streams. So let us see this program. So here you can see I have an in stream here. So I am declaring the in stream and supplying dot off method to initialize the values into the in stream, and after that I am printing the values using the system for each method in the which is present in the streams API. And here you can see after that I am using the count method, count, to store the count of the particular stream. So before that I am filtering it and I am using the count method. So like that we can use to get the count of how many elements are satisfying a particular filter condition. So now let us see the another type of streams. So here I am using the uh, stream generic type of streams, in which I am taking the string and I am taking storing the string values, and after that I am using the similar logic and I am filtering based on a contains value d. So like that I am filtering. So let us see the output of this program. So here you can see the values are printed first, then count is coming, and then later the filtered value after the predicate condition it is printing. So we are seeing in this program about how to filter and print the using streams API. Now let us see another program. Now let us discuss another program on streams. So in this program we'll have a particular stream to process a data, our user defined collection, and we will process them and use the map and all matches and any matches functionality in the streams API. So let us start this program. So here we can see them. There is a collection I am creating here, array list, and into the array list I am adding a student object. Student is a simple poser class. It consists of some fields only, and id, name, and age. And let us go back to the main method. So here You can see I'm adding the particular elements into the list, and after that I am using the map functionality. Here you have to use map is like this. First you can do any filtering or anything, and after you can use the map will map your particular uh, collection to another form. So here I am converting the integer into age equal to like that string I am converting. The mapping can be done using this map functionality, and I'm using the enhanced for loop to print the for each loop to print the particular value, and it will print the value. So I'm using the method reference of system.out.println, so that it will print the values. And after that I am using any matches and all matches functionality which is present in the streams API. So it will check whether all matches will check whether a particular condition is matching for all the values. Any matches will check whether any of the value, any of the condition is satisfied by any of the values in the particular collection. So let us see the output of this program. So here we can see mapping is done to age equal to like that the mapping will done. So map functionality is working fine, and after that any matches and all matches, this functionality is getting value true. So it will return you a boolean value whether this matching is done or not. So that's it about some programs. Now let us see another program based on the streams API. Now let us see another program based on Streams API. In this program, we will see the reduce and collectors summing in method of the collectors class to aggregate a collection and print the total salary of a particular employees in an organization. So let us see this program. So here you can see the main method. I have created an employee objects and adding this employee objects into a list, and after that I am using the free streams API here. So I want to get the total salary of a particular all the employees which are present in the organization, the sum of all the salaries, and here I am using the map method to map the particular field to salaries, and then I'm using the reduce method. So reduce is taking a lambda expression. I'm using the lambda expression to note the particular values, some equal sum plus salary, so that value will be incrementing all the salaries, and finally I'll print the values each by event. It is an optional class, so I have to use the get method to print the particular values, and finally, in the next way of doing the calculating the salaries using the collectors dot the summing into method. So this method also similar to the previous one. I'm using the streams API, and then I am using the collectors dot. You can see dot collect. In the dot collect I will use the collectors dot is summing int method. So summing int method will take a parameter of a lambda expression, and I will give the particular lambda expression to denote but salary field, and then I will print the particular value of of the total salary. So let us see the output of this program. So here you can see total salary is calculated by both methods. So this is how we can use a collect method and reduce method in Streams API. So now let us see another program based on Streams API. Thank you. Now let us see a final program based on Streams API. So let us see this program. In this program, I will convert from a list to a map using Streams API. So let us start this program. So here we have an user-defined data type employee. In that, I will have particular objects I will create for the user-defined data type, and then I will add all the values to a list one by one. And after that, I am using the streams API dot collect method, and in the collect method I am passing the collectors dot to map. In that I will pass the key mapping and value mapping like this. So particular key what I want to place and particular value what I want to get. So those values I have to pass as lambda expressions. So like that I will pass, and after that I am using the system dot out println to print the particular map which you get finally. Let us see the output. So here we can see the output. The map is printing, key value pairs is printing as the syntax for map. So that's how we are seeing about Streams API. So in this lecture, we are covered about Streams API. We seen methods like map, reduce, collect, and count, all the aggregation and processing of collections and all other things we have seen in this lecture. Please free feel to check out all other methods which are present in the Streams API. It is a very large API. It consists of lots of methods and a lot of interfaces and classes are present. So please take your time to check out all the APIs and learn more about this Stream API. So because it is in future, most of the programmers will use the Streams API for the processing of collections and all other elements. So thank you for watching this lecture. I'll be back with the next section. Thank you.